So we did our project on picking up brain waves, and the idea was that, let's say I wanted to pick up my heartbeat. I would have two antennas. I would put one really close to my heart and the other one a little bit further from my heart. And let's say there's radio signals or whatever coming through the air from way distance to me. What would happen is these would both receive the same signal from over there. But when you look at my heart, this one's much closer, so it would receive a stronger signal. So what we do is we take the difference, which means that all the signals in the air from a long ways away cancel out, and we are left with just the really strong signal from my heart. So in that way we can focus in on the heart signal. The problem with these is that our brain waves are at 13 hertz, which means the wavelength is over 14,000 miles. So these pick up a wavelength about yay long, which means that they're not practical because ours is miles and miles long that we want to pick up. So we changed strategy and we use these instead. Here I have a capacitor that stores energy in an electric field and an inductor that stores energy in a magnetic field. And what happens is we have an alternating current going up and down our antenna, and that means that the field is constantly changing. So what we did is to set this for 13 hertz, we took the reactance, which has to do with the inertia in the magnetic field and the reactance in the capacitor, and we set them equal to each other. And by doing that, we were able to solve and get something called a resonant frequency. And we designed these to pick up a resonant frequency that matched the frequency coming from the human brain, with the attempt to amplify that resonant frequency and pick it up. And that's pretty much a summation of how we can use antennas to pick up wavelengths from the human body.
So this is the guts of our circuit. It's an instrumentation amplifier. What it is it's actually 3 op amps together in one chip. And this one is the one from Texas Instruments, the INA 116. So what it is we'll have one input going through this one and one input going through this one. So one antenna would be here and one antenna would be here. What it does is it amplifies the signal from each of them, and then it goes to this difference amplifier and subtracts one signal from the other and sends it out here. So we're left with just the signal that we wanted in the first place. And we'll go through a simulation to show how it works. So here's our instrumentation amplifier circuit. We're going to model it using cadence. So here we have what we'll just model as our noise source. We'll say it's a 60 hertz 5 millivolt signal coming in. Then we have the same noise signal on this side because we wanted to have the same noise on each side. And then here's the signal that we wanted to have. So I'll show you what that one will look like. Here is that signal. This will be our heart signal or our brain wave signal. Then with the noise added in, the signal actually looks like this that's coming in. And on the other side, the noise looks very similar. But as you can see, each signal gets amplified through here, and then the one gets subtracted from the other, and we come out with the signal that we originally wanted. So that's what we were able to learn and accomplish this semester. We weren't actually able to get the circuit working, but we're going to keep working on it.